The last thing I want to talk about in section 5.2 is the upper and lower bounds of zeros. So let's let f of x denote a polynomial function whose leading coefficient is 1. Okay, and this only works for polynomials whose leading coefficient is 1. So let's edit this example. If I have a bound m on my zeros, that's going to be the smaller of two numbers. It's either going to be the smallest of my maximum, it's going to be the smallest number of all my coefficients added together. So the absolute value of my coefficients, the sum, added together, or it's going to be the absolute value of the largest coefficient. And what I do is I pick the smallest one. So now my coefficients are 1, -2, 1, and 6. So their absolute values are 1, 2, 1, and 6. My largest one is 6, so 6 plus 1 gives us 7. And the sum of my absolute values is 1 and 2, which is 3, plus 1, which is 4, plus 6, which is 10. So my bounds are going to be the smallest one, which is 7. So my bounds for zeros are going to be -6, -7, and +7. That means I'm not going to have a 0 above 7 or below -7. Let's take a look at another example. So if I have x squared minus 4x minus 2x cubed minus 7x squared plus x plus 6, my coefficients are 1, -2, -7, 1, and 6. So those absolute values are going to be 1, 2, 7, 1, 6. Remember, absolute value just takes negative numbers and makes it positive because we're measuring the distance from the origin. My largest absolute value is 7, so 7 plus 1 is 8. And the sum of my absolute values is 1 and 2, which is 3, plus 7, which is 10, plus 1 plus is 11, plus 6, which is 17. So I pick the smallest of the two, which is going to be 8. So my bound on my real zeros is going to be from -8 and +8. So I won't have a 0 below -8, and I won't have a 0 above -8. The last concept this chapter talks about is the intermediate value theorem. This is really, really important in calculus, but I want to introduce it to you now because you're going to see it again in pre-calc. So the intermediate value theorem says this. So let's let f denote a continuous function, like a polynomial, like the polynomials we've been working with. And a is less than b. So here's a, it's less than b. Here's our origin. If f of a and f of b are of opposite signs, then f has at least one 0 between a and b. So here we see that f of b is positive and f of a is negative, right? So in order to get from something negative to positive, if a is less than b, they have to have different signs. The same thing would be true if I had to get from something positive to something negative. I still have to cross my x-axis, so there's going to be at least one 0. That's the way I like to explain it. Here is the formal definition of an intermediate value theorem. So if I have f of a is less than 0 and f of b is greater than 0, so like negative and positive, and f is continuous, then there is at least one 0 between a and b. So let's use the intermediate value theorem to determine if there are zeros on these intervals. So the first thing I want to do for problem 1 is show that f of x equals x to the 5th minus x cubed has a 0 over the interval 1, 2. So I'm going to take f of 1 and I'm going to take f of 2, and if they have opposite signs, there is a 0. there exists, that's what this math symbol means, there exists a 0. So f of 1 is going to be 1 to the 5th minus 1 cubed minus 1. So f of 1 equals 1 minus 1, which is negative 2. F of 2 equals 2 to the 5th minus 2 cubed minus 1. So I have 32 minus 8 minus 1. That's going to give me a positive 23. So because f of 1 has a negative sign and f of 2 is positive, there is a 0 between the two. There is a 0 on the interval 1 to 2. All right, so let's check if, for number 2, if there's a 0 over the interval negative 1 to 0 on f of x equals 8x to the 4th minus 2x plus 5x minus 1. So f of negative 1 equals 8 times negative 1 to the 4th minus 2 times negative 1 squared plus 5 times negative 1 minus 1. Oops, zoomed in there. Let's zoom back out. Minus 1. I'll erase my little mess. So I have that f of negative 1 equals 8 minus 2, because negative 1 to the 4th is positive 1, and negative 1 squared is 1, minus 5 minus 1. So 8 minus 2 is 6. Nope, that's up. Eight minus 2 minus 5 minus 1. Well, that's going to be 0. So yeah, there's a 0 over this interval because I just found it. Great example, Miss Miller. Okay, let's check out f of 0. F of 0 equals, if I plug in 0 for all my things, I'm just going to get negative 1. So there is a 0 over this interval. Let's check on the interval from 0 to 1. Let's see if there's an interval, a 0 for this polynomial over the interval from 0 to 1. If I have f of 0, I know that's negative 1. Awesome, I already did half my problem. F of 1 is going to give me 8 times 1 to the 4th minus 2 times 1 squared plus 5 times 1 minus 1. So f of 1 equals 8 minus 2 plus 5 minus 1. So that's going to give me 8 minus 2, which is 6. 6 plus 5, which is 11, minus 1, which is 10. So yes, there is a 0 over the interval 0 to 1.